This is another talk where I started off wanting to talk about something completely different and started working on pictures and ended up with this. So here we are looking at graphs, graph databases, graph models to model people and their transactions. In this case, we're going to do credit card transactions. And the basic idea here is we're kind of taking a fraud view of this. So why don't we start off first and look at a person and their transactions. So we don't have to worry about tables or anything else. We're just going to draw graphs. And one of the interesting thing about graphs is we have nodes and we've got edges. We've got vertices and edges, or arcs, right? And so all of these are entities. They can all have additional properties, and I'll actually spend more time on this in a different one. And all the arcs have names. And so some of these I didn't add a name, and that's my fault. I should have added it. So we have a person and their addresses, and we've got a phone device, and then we're going to do a transaction that's a credit card transaction. And that transaction is actually on a card, which actually has a home address. So here we have two different kinds of home addresses, two different kinds of addresses. Now, they'll be the same vertex, but I drew them differently here. They'll be the same vertex type, but we have names, right? So when you do a transaction, we have a ship to address. In this case, I did used, and we'll have a ship to address here also between the card and the address. This card probably should also have an address to the person, but I didn't want to make this very complicated. And then if we ordered this on the device, like a phone or a tablet or maybe even a computer, we might be able to use a device identifier or something else, and we know this transaction was ordered on this device, and we somehow in the person, we have a relationship for owned phones and for a set of addresses, right? So if they're a customer, they'll have multiple addresses potentially for different reasons. I didn't type these here, but there could be multiple. And then we'll have one or more phones, right, or devices. And the only other thing here, because I'm kind of looking at fraud, so the fraud could be I have multiple people that are actually the same person, and we want to identify that. Or it could be that I have a group of vendors working together that are really the same vendor, and they're all willing to suck in kind of weak transactions. So in this case, I did a transaction with a vendor. I have a vendor contact, which is going to be a person, and that vendor is located at an address, and I'll show you why in a minute. So if we wanted to, one way we could do this, so here's two people who did two transactions. And so on the left-hand side, we have one person and the address and their phone and their card address and their transaction and the vendor that they bought from and what the vendor's address was, right? And in this case, I didn't do a billing address, which is probably dumb, but I did a ship to address, right? So the address, the transaction and the address, let me click on this because that'll make it a little bigger. And then on the other side, we have the same thing, right? So if the phone device is the same, they might or might not be the same person, right? If their address is the same, they might or might not be the same person, because like my spouse and I share an address. But it could be that, anyway, and then, so what we're trying to figure out in a fraud case, or even in a marketing case, right? Fraud case, let's take, are these two people really the same people doing bad things? And it could be they have a bunch of credit cards, they ship them all to the same address. A lot of times they'll ship them to nearby addresses, right? I ship it to my neighbors and I pick it up before they get it. And so the address might be close. So in that case, these dots represent possible similarities, and we might create an arc called similar people, similar address, or nearby address. And we might bucket it, like kind of like you bin in machine learning. You'd be like, are they close? Are they super close? Is it really the same address? They put a suite number on it, but that building doesn't have suites. And then the phone device, is it the same phone device? People might do a VPN and they'll come in on a different IP, so we might not be able to reliably use that. But do they know how to switch identifiers? So all of these dashed lines might actually be additional relationships that after machine learning or something else, we apply those edges, right? So we have an order, it's shipped to, it went to this vendor. And then what we can do here, what we did up here, we can do the same thing down here, right? So sometimes you'll have fraud rings and the vendors are living near each other, or their addresses, they're in the same building. And they have a bunch of suites. We've got 200 suites in this tiny building, the size of a phone booth. And so it may be that you geolocate those. And if they're nearby, maybe you start to wonder if you've got a fraud ring that's near each other. So one of the questions though is, hey, I did this transaction with this vendor. I might have the same vendor contact for multiple vendors. Or if I tied them into the same person database I have here, their addresses, their home addresses might be the same, even though their names are different, right? And so in this case, the important thing here is if we were to track, so part of the way we might drive this is for the transaction, we have a transaction with a vendor. There might be so this is like the transaction, the order vendor, I call this edge, right? I might also have a fraud edge, and then the percentage chance that this is fraud. So now we have transactions to vendors with an extra fraud relationship. And in the graph database, you can navigate from node to node across any of these edge combos. So you can go through a node to other nodes. And you can have circular pieces. So in this case, what we're going to try and do is we're going to try and externally process this graph and try and figure out, are these the same or similar addresses? Maybe they're historically the same. This person used to live with this person and now they're out, right? Are the phone devices the same? And then we want to look for vendor relationships also here. Are they really a bunch of vendors that are just bad vendors and they're going to do fraud? So that's pretty much what we want to do. We are going to make use of a graph database to model a person and their transactions, and we can do it natively. And we can create circular relationships, like we might go from a person to an address to a vendor to that to that primary contact back to the same address, right? So probably the only other thing we do here in a situation like this, so these we're all doing close and similar. Now, that's a little weird. If this person did 20 different fraud things, then I've got 20 weird mesh thing between the 20 different people, right? So the other way to do this is exactly the same graph, but in this case, we took all the people we have, and by applying the matching rules, we come up with a confidence level that these two people are the same people. We had that before. But now what we do is we throw out abstract people. We're going to create this notion of a person entity, and we're going to find all the people we've dealt with that we think are that person entity. So if we were to get these on different channels, we'd be able to join these together to this identified person, and then we would start looking at relationships with those identified people to see if they were part of fraud rings or fraud clusters, or if they were did a lot of transactions with vendors who happen to have fraud clusters. So that's really what I wanted to talk about. It was this notion that we could use graph modeling to do relationship mapping between different types of entities, and we can have named relationships. So you can have multiple relationships between two entities, and those relationships could be named. And that's really it, because I'm out of time. I hope that's useful. There'll be another one that's slightly different than this, another take on a side view of it. Have a great day.